Hello, I'm Boo-kyung Lee from Dongguk University Detail Lab. The paper I will review is Assessing the Infringement Risk of Patent Portfolio Using Network Analysis and IF-TOPSIS, a case of standard essential patent portfolio in ICT industry. First, this is the bibliographic information for the paper. This study proposed a combined approach using network analysis and IF-TOPSIS. The contents are the same as structure of the paper. First is the introduction. Due to the intensification of technological innovation, competition, and the improvement of patent protection in modern society, the patent infringement risk faced by company is exacerbating. And to counter this risk, company build comprehensive patent portfolio that enable countersuit and cross-licensing. As portfolio size grow, the overlapping protection scope with competitors increased, leading to higher risk of unintentional infringement. Traditional single patent risk assessment methods are insufficient, so a portfolio level evaluation approach is needed. So this study aims to propose an approach to assess and rank the infringement risk of a company patent portfolio relative to the patent portfolio of each of its competitors. So, to achieve this aim, a combined approach using network analysis and IF-TOPSIS is proposed. Next is the literature review. First is method for patent infringement risk assessment and patent portfolio analysis. Patent documents contain abundant technical and legal information and are the primary data source for patent infringement risk assessment due to their easy accessibility, official reliability, and standard format. The existing patent infringement risk assessment method can be categorized into two types. They are only applicable to individual patent level, assuming that patents are independent for each other and the infringement risk of one patent is unrelated to other patents. While this assumption is valid in use context such as engineering, design, and infringement risk assessment of individual patents, it does not hold in patent portfolio where interconnection and specific structure exists. Next is indicator of patent infringement risk assessment at patent portfolio level. As the scale of patent information continues to grow in recent years, patent portfolio analysis methods have been widely used in technology monitoring and forecasting, R&D partner assessment, and R&D planning, patent portfolio valuation to help company make strategic management risk decisions. But most of the existing patent portfolio analysis methods define their patent portfolio indicator as the average or sum indicator value of all the individual patents in the portfolio. The patent portfolio is only regarded as the simple set of individual patents with core weight without considering the weight difference of core patents in the patent portfolio and the structure characteristic of the patent portfolio. Next is the social network and patent network analysis. Social network analysis is a method for studying social network composed of a set of interrelated object which has been widely used in social science. As the defined of a patent portfolio is similar to that of a social network, SNA has been introduced into the analysis of patent portfolio in many industries. However, in the existing research, SNA has rarely been used to serve to the aims of patent infringement risk assessment. The one-mode weight patent proximity network can directly reflect the technical influence of each patent in the patent portfolio, making it suitable for assessing the infringement risk of patent portfolio. Some measure of node and network structure commonly used in SNA and their implication in the one-mode weight patent proximate network are introduced as follows. Next is the IF-TOPSIS method. IF-TOPSIS is a method that integrates IFS and TOPSIS method. An IFS A in a finite set is an object expressed as follows. Compare with classic fuzzy set, IFS and express fuzzy information for accurately by not only the membership degree but also the hesitancy degree. TOPSIS is a method that can be used to rank alternatives by calculating their distance for ideal solution. So it is suitable for the aim of this study to assess and rank the infringement risk of patent portfolio. Next is approach. First is the establishment of an indicator system. PT1 and PT2 can be calculated by using the IFWA operator as follows. Related patent portfolio position, relative average family size, and relative average claims are relative indicator defined as the ratio of the corresponding patent portfolio attribute value of the company to that of its competitor. The higher these relative indicators are, the greater the company's competitive advantage in terms of the strength and coverage of its patent portfolio protection compared to this competitor, resulting in a reduced target risk PT1 and PT2. The growth rate of portfolio patent over an X year period can be calculated using the following equation. It is designed as a quantitative indicator in this study, and its type and expression using IFS are shown in Table 2. Relative average weight degree, relative diameter, and relative density are relative indicators that depict the relative structure, strength of the patent portfolio, and defined as the ratio of the corresponding patent network measure of the company to that of its competitor. Next is the combined approach using network analysis and IF-TOPSIS. The procedure of the combined approach of assessment the infringement risk of patent portfolio is as follows. First, select and search the patent portfolio for the company and its competitor that require infringement risk assessment by the company's technology manager and patent attorneys through an iterative search process. Next, based on all the patent data obtained in step 1, an overall one-mode weighted patent proximity network containing both the company's and the competitor patent portfolio is constructed using the software. In this network, patents are represented as nodes, while IPC co-occurrency between patents are represented as weighted edge. After calculating the eigenvector centrality of each node in the overall network, the patents belonging to the company with the highest eigenvector centralities are identified as the company core patent, or their objective weight can be calculated. Next, in step 3, this study constructs one node weighted patent proximity network for the company and each competitor separately and calculate the average weight, degree, diameter, and density of each network so as to provide data for subsequent processing of indicator. Next, in step 4, first, the indicator value are normalized using the following formula, and based on the normalized value, the membership degree, non-membership degree, and hesitation degree are calculated, and the calculated pairs are used to construct the IF-TOPSIS metric, which compare the infringement risk between the company and its competitor. Then this study calculates the institutionalistic fuzzy entropy to evaluate the information uncertainty of each indicator, and a lower entropy value indicates a higher level of information usefulness, and therefore a greater weight should be assigned to that indicator. Accordingly, the entropy-based weight of each indicator is calculated. Next is step 5. In this step, this study constructs aggregate institutionalistic fuzzy assignment metric of the dimension layer, and the entropy-based weight of each indicator is calculated. Next is step 6. In this step, this study constructs aggregate institutionalistic fuzzy assignment metric of the dimension layer, and the entropy-based weight of each indicator is calculated, and rank the IF-TOPSIS result of the target risk for all competitor. The competitor Ti and T'I are compared with the theoretical highest risk IF-TOPSIS 10 using the normalized Euclid distance. The next is case study. This study selects the SAP portfolio data of various companies in the representative Chinese market as text data to demonstrate the practicality and variability of the approach. Since Huawei holds the largest number of Chinese SAP, this study selects Huawei's SAP portfolio as the company's patent portfolio, requiring infringement risk assessment. The SDP portfolio of the top 5 companies were selected as competitor patent portfolio. For comparison, the SDP portfolios of lower ranked were also included as competitor portfolios. Table 6 presents the calculated SDP portfolio attribute of Huawei and its competitor. Based on all the 6,736 SDP data obtained in Step 1 and on overall one mode weighted patent proximity network containing Huawei's and competitors' SDP portfolios in constructed and visualized in Figure 4. Then, after calculating the eigenvector centrality of each node in the overall network, Huawei's 5 core SCP with the highest eigenvector centralities were identified. Table 6 is a result of calculating their objective weight. Based on Huawei's or its competitor SDP data obtained in Step 1, one mode weighted patent proximity network representing the SCP portfolio of Huawei and its competitor are also constructed separately. Examples of the network are visualized in Figure 5. Then the structural measure of each network are calculated as shown in Table 7. Next is Step 4. First, technology management and patent attorneys search for similar competitor SCPs filed before 2017 through an iterative process based on the essential technical feature of Huawei's core SCP. And then the indicator layer intuitive fuzzy assessment metrics are constructed for Huawei's SCP portfolio being infringed on by competitor and for Huawei infringing on competitor SCP portfolio. Next, the objective weight of the indicator in each dimension is determined as follows. In Step 5, the dimension layer intuitive fuzzy assessment matrix of the target risk and is aggregates as follows, and the objective weight of the dimension for targets is determined as follows. In Step 6, the IFS result assessing the risk of Huawei's SCP portfolio being infringed on by the competitor and the risk of Huawei's infringing on the competitor SCP portfolios is calculated as follows. Finally, the competitor IFS results for the target risk are ranked in ascending order according to their normalized Euclid distance from the ISF 10 representing the theoretical highest risk. The ranking result predicted by the approach match the actual litigator and cross-licensing activities between Huawei and its competitor. Based on the ranking result of PT1 and PT2 and the company's patent network structural strengths, several managerial implications can be derived. For a competitor with high PT1 and PT2 ranking, the company should actively engage in negotiation, litigation, and cross-licensing while reinforcing the defensive and application patent layout and design its core patent around similar patents in this competitor portfolios. For competitor in middle range of PT1 and PT2, the company may face lawsuit or licensing when PT1 is higher than PT2 and pursue cross-licensing when PT1 is lower. For a competitor with low PT1 and PT2 ranking, the company should adopt defensive management strategies such as responding only when sued. Next is the conclusion. This study offers a novel patent portfolio perspective for technology risk management and a combined approach using network analysis and IF-TOPSIS is first applied to the infringement risk assessment of patent portfolios. Also, a case study of SAP portfolio containing a total of 6,736 SAP in the ICT industry is present. However, it still has some limitation as follows. Although the structured patent proximity network have special applicability in assessing the infringement risk of large patent portfolio, the information derived for IPC co-occurrency in this network is limited. The case study only tests the representative SAP portfolio in the ICT industry.